Hi there, this is Math 6, Unit 7, Lesson 4, Ordering Rational Numbers. So we're going to be ordering some numbers today, and so we've been doing some comparisons with greater than, less than, or equal to. And so first we'll start off with comparing these numbers here, and you want to be able to explain your reasoning for why you think one is greater than, or less than, or equal to. Remember, essentially what we've been saying is that if a number, let's go with a 0 here, and we'll put a 2 over there, and we'll put a -4 over here. If a number on a number line is to the left of one on the over here, we usually say that to the left of it means it's going to be less than. If it's to the right, it's going to be greater than. So for example, on a number line with showing 12 and 19, if 0 is here, we'd have 12 and we'd have 19, and so 12 is to the left of 19, so 12 is definitely less than 19. It's pretty straightforward when you're looking at positive numbers that you're used to, positive, rational numbers, no problem. It's when you start dealing with decimals and fractions that it might get a little more complicated, and that's okay. Just think through where would those numbers be located on a number line. So for the next one here, we have 212 compared to 190, and I know that 200 is definitely going to be a greater number than 100, so we could write it like so. When you look at the next one, we have 15 and we have 1.5. So again, on a number line, 0's here, 1.5 might be about here, and 15 is going to be over there. So 15 is to the right, so 15 is greater. On this next one here, sorry, kitten walking by. The next one here, I like to think the ones like this in terms of like money, right? Just add an extra decimal or extra 0 right here. So now you have like $9.02 compared to $9.20. Alright, now really it's not that, it's 9 and 200ths and 9 and 2/10, but we could definitely see in terms of money, 20 cents is greater than the 2 cents. So the 9s you don't really worry about comparing because those are equal. We're looking at the next digit over. In terms of the tens place, we have a 0 compared to a 2, and the 2 is greater. So that's how we would compare those ones. You do the same kind of idea here. Here we have 6.050. This is 6.05, and again, you can add as many zeros as you want to the right of a number. So the 6's, we don't worry about those are the same. The 0's are the same. The 5's are the same, and the zeros are the same. So essentially, we have the same number, which means they're going to be equal. Now for this next one, we have a decimal compared to a fraction. And this is one where you might get a little stuck, wondering, okay, well, how do I do that? Well, you could make them both fractions. You could convert the decimal into a fraction and then compare. And that's what I did. I said this is 4/10, so I'm going to write it as 4 over 10. Now I really can't compare easily a 4/10 to a 9/10 because they have a different denominator. But if I multiplied both by 4 over 4, then the denominator here would become 40, and the numerator, 4 times 4 is 16, and now I can compare 16 to the 9, and 16 is greater than 9, and so that would mean that 4/10 is greater than 9/40. Are there other ways of thinking about that? Yeah, there certainly are. You probably could estimate it by recognizing that 4/10 is about half, right? Whereas 9 out of 40 is not half, right? I would look for something like maybe 19 out of 40 would be closer to half, or a little less than half. But 9's a lot smaller than half of it, which would be 20. So you could also estimate that one as well. Looking at this next one, probably the same idea. All right, think of this. This is how many, if you have like a pie, right? And this is the pie. And if you chop this up into 24 slices, and you're talking about 19 of the 24 slices compared to 19 of 21 slices, right? 19 of 21 is almost a whole one, at least closer to one full, compared to 19 out of 24. So we would say that this one is going to be a greater fraction than that one there. Later you might learn some ways to be able to compare those and really show which is which, okay, or which one's greater or less than. But for now, you could just do some approximation and say, yeah, that's why I would say that. And for the last one here, okay, they're both essentially one away from the denominator, 16/17 and 11/12, right? So that's pretty close there. But think about what's remaining. Okay, so what's left here in terms of the little piece of pie, you have 1/17 left over here compared to 1/12, right? So those are the two slices that are left over. If you thought about the pie again and said, well, what's left over? Well, we have 1/17 compared to 1/12, right? So a 1/12 slice is going to be a little bit larger than the 1/17 slice. So now think the opposite. That means that this one has more that's been used up already than this one here. So 16/17 is greater than 11/12. All right. Again, the idea is just to be able to explain your reasoning. For the next activity, your teacher's going to give you a set of numbered cards. Order them from least to greatest. All right. So you're going to have whole numbers, you're going to have fractions, you're going to have decimals. You have a variety of cards that do that. Then, after you get those organized, your teacher's going to give you a second set of number cards. So then you want to put them in the right places. I'm going to let you do that on your own or in your class, because if I did that, I wouldn't have space to film all that. There's too many cards. So you go for that and see how that works out. For activity number 3, it says use each of the following terms at least once to describe or compare the values of points M, N, P, and R. We're going to talk about greater than, less than, opposite of, or opposites, or a negative number. So, things you could say. We could say that N is greater than M. True? You could say P is greater than N, R is greater than M. So there's a variety of things you could say that are greater than. So when you do the greater than, you'll start with the letter on the right compared to a letter on the left. So again, one might simply be that N is greater than M. Now less than, we're going to start with a number on the left. We could say something like P is less than what? What is P to the left of? To R. So P is less than R. N is less than P, and N is less than R. And M is less than N and P and R. So lots of options you could choose there. In terms of opposites, right, you're looking at the same distance away from 0. If you fold this over, remember our patty paper last time? If you fold it over at 0, which ones would line up? Well, I'm here at 1, 2, 1, 2, so it's not the N. 1, 2, 3, 4, 5, or negative 5. 1, 2, 3, 4, 5, positive 5. So we would say that M and P are opposites. And in terms of negative numbers, we could say that N is a negative number. We could say M is a negative number. Either one is just fine. All right. Now for this next part, it's a little bit tricky, and it wants you to play with this number line quite a bit and change the values of what these little hash lines are going to be, hash line marks are going to be. Right? When I marked it over here, I counted off and said this is all whole numbers, 1, 2, 3, 4, 5, and negative 5. But we want to figure out what the values would be if the given value is not just a regular whole number. So for P, it says if this is 2.5, then what are the other values? What's the value of M, N, and R if P is 2.5? So I'm going to do it with a pencil so that I can keep erasing this, because I'm going to have to change what these are. So this is 2.5. We can think of 2.5 as 2 times 2 is 4, plus 1 is 5, as 5 halves. And what we see here is that we have 1, 2, 3, 4, 5 halves, right? So that would mean that this is a half, this is 1, this is 1.5, this is 2, this is 2.5, 3, 3.5, 4. Okay, you alright with that? On the negative side, this is negative a half, negative 1, negative 1.5, negative 2, and the opposite, negative 2.5. Remembering that the opposites are here is going to make this activity a little faster, right? M and P are opposites, so M is going to be an automatic negative 2.5. N is over here at negative 1, and R we said is at 4. And because each little mark represents a half, we can count it out and go 1, 2, 3, 4, 5, 6, 7, 8, and 4 divided by 8 is, or 8 divided by 4 is 2, and so you get halves, and so anyways, or 8 divided by 2 is 4. So that's where we have 4. All right, let's look at the next one. It says N is negative 0.4. So we want to find out m and p and r this time. Alright, so I'm going to erase these numbers because that's not the value I'm working with anymore. So I'm changing the scale, so to speak. And it says that n is at negative 0.4. Okay, so if we're counting by 0.4 to go there, then that would make this 0.2 because it's halfway between there. So I'm counting by 2/10. So we have negative 0.2, 0.4, 0, negative 0.6, negative 0.8, and this becomes negative 1. So m is at negative 1. P, remember, is the opposite, so this is regular old 1. And then we can continue counting. We have 1.2, 1.4, which makes this one 1.6 for R. Alright. For the next one, we're going to look at R, which means we have to find M and N and P. And we'll erase our values here. And it says that R is 200. So that's 200. We knew that it was 8 to get out there before, so let's figure out where 100 is going to be. If this is 8 away, then 100 is going to be 4 away. 1, 2, 3, 4. So this is 100. And I can see that between 0 and 100 are 1, 2, 3, 4 lines, which means if I take 100 and divide it by 4, every mark is going to be a value of 25. So this is 100, then this makes P is 125. And if I know that P is 125 and M is its opposite, M is a negative 125. And then counting down this way, if this is negative 25, this becomes negative 50. And that's that one. And let's look at one final one here. Erase all this. We have M is at negative 15, so we have to find N and P and R. So if this is negative 15, and I have 1, 2, 3, 4, 5, then what I'm going to do is I'm going to do 15 divided by 5 gives me 3, which tells me that each mark here has a value of 3. So I count by 3, negative 3, negative 6, negative 9, negative 12, negative 15. So N is located at negative 6, P is the opposite, so it's going to be positive 15, and counting by 3s, I have 15, 18, 21, and 24 for R. Alright, and that's the idea for that one there. You have to play with that number line quite a bit. Let's take a look at our summary, because that really is our whole lesson right there. To order rational numbers from least to greatest, we list them in the order they appear on the number line from left to right. For example, we can see these numbers are listed from least to greatest because the order they appear on the number line. Negative 2.7, negative 1.3, and 0.8. Right? That's just how the number line works. And we organize them from least to greatest from left to right. And that's what we're working on today. Hope that gives you an idea what to do. We'll work on your homework next, and we'll see you in a minute to check it out. Alright, homework time for Unit 7, Lesson 4, 6th grade, ordering rational numbers. Select all of the numbers that are greater than negative 5. So again, if we're thinking about a number line here, and negative 5 is right there, here's 0, when you put this number on a number line, is it going to be to the right of? Because if it's greater, it's going to be on this side. So anything from here on over is going to be okay. So 1.3, we'd put that somewhere over here, right? So that's where we'd place that, so that definitely is going to be greater than. Negative 6 would be on this side, that one's not going to work. Negative 12 would be over here, that's not going to work. 1/7, it's a fraction, so it's between 0 and 1, so we could put it over here at 1/7, that's just fine. Negative 1 is here, and even though it's negative, it's still to the right of, this is our cutoff point there, right? So everything to over here is going to be just fine. And so negative 1 is also just fine. Negative 4, it's still to the right of negative 5. That's just fine as well. So you have 4 answers that are going to work out for you just fine. Order these numbers from least to greatest. Okay, so we have some negative ones. We have these guys are negative. we have 0, and we have some positives. So looking at the negative numbers, the first one, if you put it in order on a number line, let's put a 0 right here. Let's go with a 1. Let's go with a half, another half, and a 2, a half, and a -1, a half, and a 2, -2. So for us, we have a half, which is right here, 0, which is obviously right there, 1, which is here, -1.5 is here, -1/2 is there, and -1 is there. So our order is right here. -1.5, -1, -1/2, 0, half, and 1. It's helpful to show that on the number line so you can show that you actually know what's going on. Number 3, here are the boiling points of certain elements in degrees Celsius. We have -185.8, -34, -188, -252, and -153. For something like this, the decimals are not a big deal, right? So don't worry about that. We have some decimal numbers, but we're talking mostly about numbers that are going to be compared on, the regular numbers here. So we don't have to worry about the decimals too much, most likely. We're going to go from least to greatest. So thinking again about the number line again, which ones is the furthest away? They're all negative, so I can start put my 0 over here. And if I did, and again, just plot these out. Let's just stick right here at -185.8 for argon. Okay. Now -34 would be to this side of it. Don't worry about the spacing, but I know it'd be over here. So that's chlorine. Fluorine, -188. That's gonna be on this side. Hydrogen is further this way, so -252. And krypton, which is -153, is to the right of argon. And there we go. So again, plotting out on the number line, we can see that I'm going to have hydrogen, fluorine, argon, krypton, and chlorine. All right, so that's the order there, and you can see how that works on the number line and prove that that's right from least to greatest. Okay, for number 4, I want you to explain why 0 is considered its own opposite. So you're going to write something down with some words here for why 0 is its own opposite. I'm going to let you do that one there because it's a great little question for you to think about. All right, I'll move to the next slide. We'll explain how to do these calculations mentally. So just some mental math for how you might solve these ones here. All right, so let's talk this through. So for A, the way I would probably do this one here is recognizing that this is about 100, right? So knowing that it's about 100, I think about 100, I think about this as 100 plus 54, which is 154. And then I remember that I added one more, so I take one away to have 153. Over here, again, this is about what? It's about 100. So it's 244 minus 100, which gives me already 144 as an estimation. But because I subtracted one more than I needed to, I need to add one back to it, so I'd have 145. Because I took one away more than I needed to. Same idea here. This is about 100, right? So 100 times 6 is going to get you 600, no problem. But I basically added one extra 6. When you multiply, you're doing groups of. So I did one more 6 than needed, so I need to subtract 6, so I'd be at 594. And this one here again, I have about 100 times 15, which is going to be about 1,500. And I need to subtract 15, which puts me at 1485. All right. Moving down, number 6. Find the quotients. We have a half divided by 2, or 2 over 1, 2 over 1. Let's see what we have here. So when we're dividing fractions, we're going to multiply by the reciprocal. So that becomes a half times a half, which is 1/4. Here we have 2 times the reciprocal, becomes 2 over 2, which is equal to 1. This one, we multiply by the reciprocal. So the reciprocal of a half is 2 over 1, becomes 2 over 2, which equals 1. And here we multiply by the reciprocal, so we have 79 over 38. That can cancel and cancel, or reduce, reduce, reduce. So I end up with 1 over 1, which equals 1. All right, over several months, the weight of a baby is measured in pounds doubles. Does its weight measured in kilograms also double? That's the question. So let's think about this. I have if let's see, yeah. So first of all, it's 2 pounds, right? And then the next month it doubles, so it becomes 4 pounds. Then after that it doubles and becomes 8 pounds. After that it doubles and becomes 16 pounds, right? Okay, no problem. The question really is, does the word pounds here, the label, actually matter when you're talking about if we switch it to kilograms? If I had 2 kilograms, oops, and we doubled it, would this number double? Yeah, it would double. It would double to 4. Does it matter what we call it? Not really. It doesn't really matter. Think about how often you guys don't even use your units. You don't put labels on it. You don't say if it's inches or centimeters. You forget that all the time. So the numbers work out, all right? When you do your work, you get the right numbers, but you forget your units. And sometimes your teacher might say, oh, you got to write the right units to get full credit. Well, in this case, they're saying, well, if you change what the units are, do the numbers have any difference? No, they don't. Because if this is 2 pounds, right, I don't know, that might mean that it's going to be, I don't know, let's say with 5.1 kilograms. I'm making that up. I have no idea. So if it was 2 pounds, we switch to kilograms, well, what will we double? We double that number. That number becomes 10.2. It's not going to be like just add 2 or to this one. We're actually doubling the number. So since you keep doubling the number, it's going to be doubled as well, no matter what unit you use. So hard to write that out. I'll let you figure it out on your own. Okay, have a great day. We'll see you next time.